everyone and welcome back to Study Room. So in today's lecture, we will be dealing with a topic that is mapping spaces around us. Now, you must have all seen various types of maps. The world maps, maps of our own country that comprises of the different states. So, have you ever wondered that how is it possible for us to confine the countries and the continents that is so large a space within a small piece of paper? It's interesting, isn't it? So, this is possible only by knowing how to map spaces around us. So, let us now study how to map spaces around us so that you will be also able to make a draft of your community or locality you are residing in within a small piece of paper. Now, many of you over here may like painting and drawing pictures, and we all know that perspective is really important for painting. But in case of mapping, perspective is not that relevant. So, let us learn what are the important things that we need to learn and keep in our mind before mapping. The very first thing that we need to learn in mapping is that the different objects, they are represented as symbols. Now, we have a house. So, let us represent a house with a rectangle on the map. We have trees on the street. Let us represent trees with circle. So, symbols are very important in mapping. We use the symbol to represent the different objects. And also, we have to mention the distance between the two objects on the map. For example, in real life, we have a hut and we have a tree. So, there is some distance between the hut and the tree. Now, if we are representing the hut with a rectangle and a tree with a circle, then we have to mention the distance between the rectangle and circle on the map. So, let's say I'm writing 2 centimeter is the distance between the rectangle and the circle on the map. So this makes reading the map much more easier. Now, this distance that I have mentioned, that is 2 centimeter on the map, should be proportional to the actual distance in real life between the hut and the tree. And this can be done using a proper and a suitable scale. Now let me explain to you what is actually this. What happens is that if let's say we have the actual distance between the hut and the tree as 1 kilometer, let's say. So, in the map, when I am doing this thing, I am mentioning that the distance between the hut and tree is 2 centimeters. So, I have to mention a proper scale. That 2 centimeters on the map actually means 1 kilometer in real life. So, a proper scale needs to be mentioned when we are writing the distance between the two objects on a map. So, the 3 things important is, we have to use symbols to represent the different objects. We have to mention the distance between those symbols. And then using a suitable scale, we have to write the distance of those objects that is between the two objects. And that should be proportional to the real distance between them. Now, let me tell you the difference between drawing an actual picture and mapping. When we draw a real picture, then if I am the observer, I am drawing a real picture. So the tree that is right in front of me, I will be drawing the tree of a larger size as compared to the tree that is a bit away from me. But in case of mapping, references and perspective holds no meaning. This means that the object that is right in front of me should be represented of the same size as compared to the object that is somewhat far away from me. If I am standing over here, I have a tree right over here. Then I'll represent that tree of the same size as to the tree that is 10 kilometers away from me. All the trees on the map will be represented of the same size irrespective of the reference point, irrespective of the observer. So, this is very important in case of mapping, and preferably the objects are represented using symbols. Let's say trees are represented by circle. So, we have to represent all the trees with the circle of the same size. So, we can say that in mapping, references and perspectives holds no meaning. There is no reference, no perspective. Now, let us conclude all the points that I taught you about mapping. So, why do we learn mapping? Mapping is basically learned in order to depict the location of a particular object or a place in relation to the other object. If I want to depict the location of my house with respect to the railway station, so I will be depicting it on a map. So a map is very useful if I have to depict the location between the two places. Now the second thing that I taught you is that whenever we are mapping, we have to use symbols in order to represent the different objects. So symbols are used to depict the different objects or the different places. For example, if I have to depict a playground, let's say I will take a circle to depict the playground. So we have to use symbols in order to depict different objects or places. Now, the last and the most important thing in mapping is that we have to fix a scale, and every map has a particular scale. Now, this fixing of a scale is important because it helps us to depict the distance between the two objects on the map. This actually reduces the real distance between the two objects in proportion to the distance on the map between the two objects. So, these are the 3 points that we need to keep in our mind while mapping any object or any space around us. Now that we have learnt about mapping, I will be teaching you about faces, edges and vertices. First thing is faces. What is a face? Face is simply a single flat surface. Let me show. Here we have a cube. So, in the cube, this front portion, this is a flat surface. So, this flat surface is a rectangle. No, it's a cube. So, this flat surface will be a square. So, face is a flat surface. A single flat surface will be known as a face. Next up, we have vertex. What is a vertex? A vertex is actually the point where 2 or more line segments meet. Let us take this point as A. I will say that A is a vertex. Why? Because A is a point where 3 line segments are meeting. How? We have this line segment, again we have this line segment, and again we have this line segment. So altogether 3 line segments is meeting at this particular point A. So A is known as vertex. Now we have edge. What do you mean by an edge? An edge is a line segment between 2 faces. Now I taught you a face. Face means a single flat surface. So let us consider in this cube, we have this front face and we have this back face. So I told you that an edge is a line segment joining these 2 faces. So the front face and the back face is joined by this line segment. So this line segment is known as an edge. Also, we can say that edge is a line segment that is joining 2 vertex as well. Let us consider this vertex as A and this another vertex as B. So these 2 vertex are joined by a single line segment AB. So AB is also known as an edge of a cube. So to summarize it, vertex means a point of intersection of 2 or more line segment. Edge means the line segment that joins the vertices or the line segment that joins 2 faces. And what do you mean by face? Face is a single flat surface. Now I'll be teaching you what is a polyhedron. So polyhedron is a solid that is made up of the polygonal regions. Now what are these polygonal regions? Polygonal regions are the one that I taught you previously. Faces, edges and vertices. Now what happens is that when we have the faces they meet up at the edges. Those are the line segments. And then the edges they meet up at vertices. Vertices are the points. And then all together these faces, edges and vertices gives rise to a solid shape, and such a solid shape is known as a polyhedron. Now let us have a look at some of the polyhedrons. So the examples given in this block represents polyhedron. Now why these figures are polyhedrons? Because in each and every figure given in this block, we have the faces that meet up at the edges. Edges are the line segment that join the faces. And again the edges, they meet up at a single point which is known as a vertex. So this criteria is being satisfied by each and every figure given in this block. So that is why all the solids are known as polyhedron. But on the contrary, over here, these solids are non-polyhedrons because here we have a sphere, a cylinder and a cone. These 3 solids are non-polyhedron because here the faces, they are not joined up by the edges and the edges are also not meeting the vertices. So basically this is a solid which is not produced by polygonal regions. So that's why they are known as non-polyhedrons, whereas the figure given in the first block represents polyhedrons. Now, how will you distinguish between a polyhedron and a non-polyhedron? So let me tell you that whenever you get some figures that have curved faces, so they will be a non-polyhedron, because solid with curved faces, they are non-polyhedrons. Let me give you some examples. Like we have a sphere over here. In a sphere, we have curved face. Again, in a cone, we have curved surfaces. And in a cylinder too, we have curved surfaces. So in all the solids that we have curved surface, they are known as non-polyhedrons. So it can also be said that non-polyhedrons can be described as those solids which have sides that are not polyhedrons. So in this way, we can distinguish between a polyhedron and a non-polyhedron. Whenever you see a curved surface, then simply tell that it will be a non-polyhedron. It's a solid, but it's a non-polyhedron solid. Now let us discuss another subcategory of polyhedron, that is convex polygon. Now, convex polyhedron is a polyhedron with each of its interior angle that is less than 180 degree. So, whenever we have interior angles, each of them less than 180 degree, so that polyhedron will be known as a convex polyhedron. Another important thing is that the diagonal of the convex polyhedron will lie in the interior of the solid. No part of the diagonal will go outside the solid. So, this is another criteria for a convex polyhedron, that the diagonal lies within the solid and it does not lie outside the solid. None of the portion will go outside. Everything will lie in the interior of the solid. Here we have been given examples of convex polygons. So, this is a cube, this is a convex polygon, because the first thing is that each of the interior angle is less than 180 degree and the diagonal lies completely within the solid. But here, these two are examples of non-convex polyhedron because the angles are not less than 180 degree and the diagonals, they lie on the outside of the solid. Now, I will be teaching you what is a regular polyhedron. So, before that, let me teach you what is a regular polygon. A regular polygon is a polygon made up of equal sides. For example, a square. In a square, all the sides are equal, so it is a regular polygon. Now, a polyhedron. A polyhedron will be a regular polyhedron if each of the face is a regular polygon. For example, a cube. In a cube, each of the face is made up of a square, which is a regular polygon. So, if the faces of the polyhedron is made up of a regular polygon, then such a polyhedron is known as a regular polyhedron. Another important thing of a regular polyhedron is that the same number of faces will meet at each vertex, which means that let's say we have a cube over here and we have a vertex A over here. So, the number of faces that is meeting up at this vertex will be equal to the number of faces that is meeting up at this vertex B and in each of the other vertices. So, the criteria is that the same number of faces should meet at each of the vertices, then such a polyhedron will be known as a regular polyhedron.